This is video 10 using PCA9685 for servos on STM32 MicroPython and the black pill. The code for this video is at the GitHub site. The information presented in these videos on MicroPython should work as well on any STM32 F4 board. All code examples have pin definitions at the beginning of the file to allow the programmer to alter as needed. As this channel covers multiple microcontroller solutions over time, please subscribe to stay informed and click like, as that really helps. In this video, we continue to use our STM32 black pill microcontroller on the car baseboard with an external PCA9685 board to perform control of up to 16 servos. A servo is a motor device that rotates a shaft to a specific position, like a steering wheel. For this video, we will use the car baseboard, the PCA9685 board from Adafruit, and a $3 MG90S servo, which is good for steering small cars or painting a small camera. The car baseboard includes a PCA9685 header in the middle of the board. The header allows a 5-pin cable to be plugged in between the two devices and no other wiring is required. The header provides logic power for the PCA9685 board. This picture shows the 4-cell battery pack providing 6-volt power to the middle terminals of the PCA9685 board. The 6 volts is distributed to the 16 V+ header pins. A servo is plugged into one of the 16 headers. The PCA9685 device uses I2C communication starting with address 0x40. The Adafruit board includes soldering pads to change a board's address, thus allowing up to 62 PCA9685 boards to be daisy-chained together via the second header. Let's begin by opening the file bb_machine_test_2c.py in Thony. Let's look at the code. The program has definitions for the STM32 I2C pins, B6 and B7. It configures the variable I2C to set up the I2C. It then performs an I2C scan and prints the devices. For now, make sure just the PCA9685 board is connected to the STM32, and let's click the green Run icon. When we do, we'll see that it prints out the addresses of all the devices attached. But wait, there's 2 addresses. Turns out this is a feature of the board. The datasheet describes that 0x70 address as a way to drive all 16 headers simultaneously as a feature called all call. The datasheet is included in the GitHub site. Let's click the red stop icon and disconnect the USB connection to the desktop. Now let's connect the servo. A servo has 3 wires as a cable. Mine are colored brown, red, and yellow. We will attach the servo cable to header 0. Connect the 6-volt power supply, and I placed a plastic attachment on the shaft to see the rotation. Now open the file bb_machine_PCA9685_I2C.py in Thony. Let's look through this code. We see that we've imported the library PCA9685 and we've imported the servos class. The code will perform a scan. The code to perform a scan is disabled by making it comments. The variable servo board is created to set up the I2C address at hex 0x40, and a servo rotates up to 180 degrees. Our code will perform 4 examples. It's going to position it to 0, it will pan to 180 degrees, it will pan straight ahead, and it will reverse 180 degrees. So let's click the green Run icon to start the program. And you can see it's done all 4 examples. Let's click the red stop icon and press Ctrl-C on the keyboard. In summary, the PCA9685 datasheet discusses the dimming of LEDs, but the device seems to have wide hobby appeal for servos. The board controls the power for 6-volt devices. The MicroPython includes classes for motors and a step motor, so look for a follow-up video. Regarding servos, there are many servos available in the marketplace. For a project, study the servo specifications and purchase the servo that has the power and torque you need. Hopefully you now have a better understanding on controlling servos with the PCA9685 board using MicroPython on the STM32 microcontroller. In the next video, we will configure the time of flight sensor. Thank you.